Hello, we're going to look at a model for the spread of an epidemic. And so we have a formula here, and it tells us n number of newly infected individuals t days after the outbreak. So our first goal is going to be to make a graph of this. We're supposed to put time up to 30 days. So when I look at my formula, time is that x variable, so that has to go to 30 days. I don't really know how many new cases there were going to be, so I'm going to have to use my table in my graphing calculator to help me with that. When I look at this formula, because there is math up here in the top of the fraction, I am going to have to add in a set of parentheses. So let's go to our graphing calculator and get this typed. So we're going to go into our y equals, clear out what was previously there. I'm going to go to my y1, and I'm going to type this. So we talked about we need parentheses to get that math in the top. So that was 67635 e with an exponent of 0.27 t, and we'll use x on our calculator for that. So I get out of my exponent spot and close my parentheses. Those of you using an older model, you'll have a double parenthesis there. So then I'm going to divide. There were parentheses around the bottom of this fraction, so 500 plus e to the 0.27t, and we'll use x again. There we go. And then I want to get out of my parentheses, out of my exponent, finish my parenthesis, and then I also want to add a squared. All right, so as we said, we know that our x is to be up to 30 days, so that's going to go 0 to 30, but we don't really have a sense of our y values. So I'm going to go to my table, second table. Ooh, this is not where I want to be in my table, so let me go and set up my table to start at day 0 and to go up by, let's just go up by 1 so we can take a look at what the values will be. So second and table. All right, so here it starts out very small, so I'm going to want my y value to probably start at 0. And as I arrow down here, because I want to go up to 30 days, okay, it's definitely climbing. And now it's shrinking again, so it looks like my maximum was in here about 33. And so I want to go to my window. Excuse me there, window. And we said x is from 0 to 30 days. And we said that our y value should probably start at 0. Our highest one was 33 point something, so I'm going to go up to 40, so I just have a little room there. So now I have a good window, and I hit graph, and I see this curve that's showing me the number of new cases per day. So let's go look at our question. We made the graph. We have time up to 30 days. Our question is, what is the greatest number of new cases we expect to see in one day? When does it occur? So really key word here is this greatest number. So let's go look at what we have on our calculator. So greatest number would be at the top of this hump, because that's obviously the highest place. And my calculator has a feature to calculate that for me. So I'm going to go second and the trace button to get to my calculate menu. I want the greatest, so I want the maximum. So option number 4. And it asks me questions, similar questions to when we had found a 0. It's asking me for the left boundary. That means my cursor needs to be left of the greatest amount. I'm pretty far to the left, so I am actually going to use my arrow key to get a little closer to that maximum value. All right, hit enter, and this model puts a line there. Other models will just put the arrow. Now it's asking me for the right bound. So I need to move over until I am distinctively to the right of that maximum. So that looks good. Hit enter. Right. Next, it asks me to guess, so I'm going to move my cursor back to where I think that top value might be. That maximum point looks pretty close. Hit enter. So it finds that x is 23 and y is 33.8. So I need to make sense of this ordered pair, and it really is in the context of the problem. So in our problem, x was the days, so this is telling me on the 23rd day, and y was the number of new cases, so this is telling me, rounding, that there would be 34 new cases. So what is the greatest number of new cases? We said, rounding to a whole number, that it was 34, because that was the y, and the y was the n, the number of new cases. When does it occur? We said it happened on day 23, because 23, the t, was where we used x, or the t, the time in days. The next question is, the local medical facilities can handle no more than 20 new cases per day. During what time period will it be necessary to recruit help from outside sources? So this no more than 20 tells me that it's an inequality. It's going to be a range of days, and I want to know where this number of new cases here is above 20. So I'm going to my calculator for this, and I'm going to use the crossing graphs method. So if I go into my y equals, I already have my formula, and for my y2, I'm going to add 20. And because it said no more than 20, I want to know when is the graph above 20. So let's look. So all of this space here is above this line of 20. That's the red line. So I can figure out when it starts to go above 20 by finding this intersection point, and when it drops below 20 by finding this intersection point. So my calculator will calculate them. Second trace, calculate an intersection. First curve, enter. Second curve, enter. And then I want to move this to where that first intersection point is. Enter. And it's at 17.4. So they're going to start needing help on the 17th day. Now I also want to figure out when will they stop needing help. To calculate that, I repeat the steps. So second, trace, intersection. Enter for first curve, enter for second curve. But now I need to move my cursor to that other point of intersection to get a different value. So my guess is that they will stop needing help somewhere around the 28th, 29th day. So let's hit enter. And so it says 28.6, so they will need help on the 28th, but not the 29th day. So going back to my PowerPoint slide, we found it was 17.4, so they will need help from day 17 to, and then it was 28.6, so they will need help on day 28, but not day 29. So from day 17 to day 28, they will need help with the new cases of this epidemic.